check. So we want to focus on this one, the last one, advanced counting using pi, and we are still using the bus and stars because we see we have two different groups that must be given any number between 0 and 13 and be allocated there so that it can, they can, when we add them, they can give us 13. So there's a restriction here. We can start by counting number 1, number 2. How many of these solutions or combination of these integers are possible where xi is greater or equals to 0? The normal one we know. So if it's greater or equals to 0, all of them might just be, as in not all of them actually, because it won't make sense for all of them to be 0 and be equated to 13, but some are allowed to be 0, then also this can just be 13 like that. So this is just the normal one. I think everyone can count this. You just go and check, okay, your stars is still 13, your bus is still 4, 13 plus 4, 17, choose 4. Then we want to focus on this because this is beyond stars and bus. It's still, no, it's not beyond stars and bus. It's still, I think they said beyond stars and bus on the textbook. Or maybe I'm confusing with the arrangements, but it's still under stars and bars, but now it's quite advanced because we are using the principle of inclusion and exclusion to get the answer. How many of those solutions have their xi between 0 and 3 for each xi? So they're saying those that are between 0 and 3. You can see that it's going to be very difficult for us to count this directly. Hence, we have to use the principle of inclusion and exclusion, where we can just go and say, okay, what we're going to do is we're just going to count the total number of them without any restriction. Then if I get the total number of combinations of them without any restriction, and from this total combination that are possible without restriction, and we go and use the principle of inclusion and exclusion to subtract those that are greater than 3, in a way, where xi is greater than 3, obviously we will be left with those where xi is less or equals to 3 and being greater or equals to 0. So the idea there is to say, I'm just going to count the total number of them without any restriction and subtract those that are above 3. So we are saying we're using the principle of inclusion and exclusion. We are saying from all of them, if we remove those that are above 3, then we'll be only left with those that are less than 3 and still greater than 0. So it becomes very challenging if I saw on one thing they put like this. So I think it was also discussed in the tutorial that you just have to create a new interval and go and solve that one, so that you work it out in that one. So that's basically what we're gonna do. What is the total combination we can make for this one? We just count the stars. Under normal condition, normal, we are saying xi greater equals to 0. We're gonna count all of them for xi greater equals to 0. Let me just not say the total because I'm giving a restriction xi greater than 0. We're gonna count how many of them are there, and we are saying from all those ones, we are just gonna subtract those that are greater than 3, so that whatever we are left with, it's between 3 and 0. That will give us the answer for this interval. So the principle of inclusion and exclusion help us to do that. So the total that for xi greater equals to 0, obviously there must be 0. We can say, okay, we have 13 stars, 13 plus how many bars? 4, choose 4. Then it's 17, choose 4 as the number of possible combination that can be made where xi is greater than or equals to 0. Minus those that are greater than 3, that are greater than 3. And we can go and see this, those that are greater than 3. we know how to count these, those that are greater than 3. If the interval say xi greater than 3, we know how to count those. These are integers. What it tells us, it's saying at least there must be 4, right? Yeah, someone can just pop in and just quickly.
Oh, that one will be 0, right? Because if we multiply 4 by all of them, then it becomes 0, because 16 is greater
What
than
will be
30.
0? What will be 0?
The ones which are greater than 3, everyone must get everything greater than 3.
Yeah. Okay. Yeah, it's true that one can argue it means the stars must be 0, because now if you give everyone greater than 3, which is 4, because we are working with integer, it won't make sense. You only have 13 if it's cookies, and if you give everything 4, 8, 12, 16, my maths is not working, 20, ne? It won't make sense. You'll have a negative, and it's not possible. Hence, we have to use it's advanced counting. In such instances, hence we have to use the principle of inclusion and exclusion to say, okay, rather than us going and give each of them greater than 3, which is 4, we can see that this won't work. Rather, what we're gonna do is from 5 of them, we're just gonna choose 1 and give one of them 4. Because we saw that if we give all of them 4, as this restriction is saying, it won't make sense. You only have 13 stars, and how can you claim to give 20 stars while you have 13 stars? So hence the principle of inclusion and exclusion has to be used to say, okay, rather than us going to give everyone, let's just start by giving 1 by 1, and let's see if we still have some stars remaining. Let's give the second one. From 5, I choose 2 people, I give them, then I count. And this is principle of inclusion and exclusion. So from 5, I give 1. Remember, I'm giving xi. I think they put it very well also in the textbook to say we're giving xy to be greater than 3. We are starting with this one. We are choosing it. So from 5, we chose 1. Then we are saying if we give this one to be 4, how many stars will we be left with? So it will be 13 minus 4, which is 9 stars left, then plus our bars, which is 4. Then this combination, the total number of combinations that can be made if we give that one, it will be 9 plus 4, which is 13, and choose 4. So that's the idea there. But we are not done. This is the principle of inclusion and exclusion. So they claim once we do this, we have subtracted too much. Then we need to add back, just like working with Venn diagram. And if you say you're just gonna subtract this Venn diagram and this Venn diagram, in the whole union of that, you realize that you have actually subtracted some of these things that falls under this diagram of A. Then you have subtracted too much. You need to add back those things. So that's the idea of principle of inclusion and exclusion. We've subtracted too much. We need to compensate and add back. That's the idea. You can just memorize. I just memorized also. I don't know if we can understand. Someone who has an understanding of why should we add back, but I think in terms of Venn diagrams also to say if you are removing and we need to add back because you have subtracted too much, you have removed some of the things that falls within that interval of things that are in that thing. So now we're gonna add back and we're gonna continue now to say, okay, we had given 1 student. Now let's go and give x1 and x2 to be greater than 3. Let's give them a value that is greater than 3. Because we notice, remember, we are only using this principle of inclusion and exclusion because we realize that if we give all of them, 4, 4, 4, 4, it won't make sense. We have 13 stars, and if you give all of them, it will require you to have 20 stars. Hence, we have to use the principle of inclusion and exclusion. So now we are saying we're going to choose 2. We are doing it slowly so that we may not exceed the number of stars we have. We are giving 2. So from 5, we are going to choose 2. We are saying it's x1 and x2. We are choosing them. If we give these 2, 4, 4, here 4, 4, how many stars will we be left with? So it will be 13 minus 8, which is 5. 5 stars will be left, plus your bars, which is 4 bars. Then the number of combination for this one, it will be 5 plus 4, which is 9. Choose your bars, which is 4. Then they also argue again to say, no, actually you have added too much in a way. And when do we know where to end or where to stop? It's when our distribution of stars are now exceeding the total stars that we have. So we can see that, okay, even the third person is possible, we can give them 4, so that 4, 8, 12. But we can't go further to the fourth person because so we'll know where to end once we realize if I go to this person, I'm exceeding what I have. So we still have one more chance there. So they claim that we added too much, we need to subtract now. That's the principle of inclusion and exclusion. So 5 choose 3, then because we are choosing 3 items, x1, x2. So this is for x1 greater than 3, x2 greater than 3, x3 greater than 3. So each of them must be at least 4. Then now it will be, it's gonna be, okay, you're giving 4, 8, 12. So from 13 stars, if I'm giving x1, x2, x3, 4, 4, 4, how many thing I'm left with? Obviously it's 1 because we are saying it's 4, 8, 12. We are subtracting 12 thing there. So it's 1. So you're only left with 1 star plus how many bars? 4 bars. And we can see this will be 5. And we choose the bars, which is 4. We can't continue any further because if you just come and give the other one 4, it's completely out. So now this will be the final answer using the principle of inclusion and exclusion. Although on the textbook they represented it quite differently, they put these brackets and obviously it will change this, but the idea is quite the same, that you just need to know that we are subtracting, we have subtracted too much, we have to add, we have added too much, we have to subtract. In a way, that's the thing they're arguing for. Then we can count the total number of these. We just press the calculator and get the answer for that. How many solutions will be between 0 and 3? What we did really is to say, okay, let's count all those that are greater than 0, and we counted all of them. Okay, from all those that are greater than 0, let's go and remove those that are greater than 3, where xi is greater than 3. And we realized something, that it was impossible for us to give each of them 4 because we were limited to 13. Then and why are we saying let's subtract those that are greater than 3, whereas we are wanting the interval 0 and 3? This allow us to only have solution that is between 0 and 3 because we have removed all those that are greater than 3. So the solution that will remain here will be between 0 and 3. And that's how we do the advanced counting using the stars and bars.